As I say, I'm Stephen Shanley, and as John said earlier on, we'd come across each other on sites, and as he said, with the new technologies coming forward, it is something that clerical works or building control they haven't been familiar with seeing. So it was just to try and give an insight into what the different type of units are, and how they're behaving, how they should be installed, and the general points for yourselves as clerical works or from building control to be able to go out and investigate and just make sure that you're happy when you're leaving your site inspection, that as well as everything else you're checking, that you're happy with the heating component that's there. As with all new houses, everything's aerated, so the heat pump is becoming more and more part of that. You will still see gas boilers or oil boilers in some new developments, but more and more we're going to be seeing the heat pumps. And in apartments over there we have ventilation units as well, so that's what becoming more prevalent. Those we'll talk on those later, but for now we'll just stick to what you're going to be coming across in most of your houses, which is a heat pump. So there's a couple of different types, and we have them set up here. This just happens to be a particular manufacturer that here. It's nothing that all manufacturers' units will basically do the same. They all have to meet CE MART and compliance. So it's just most manufacturers' units will look similar. So you'll have lots of different brands. So that's it. You can start on this unit here. Is what we call a monoblock. It's the bigger of the outdoor units, and it will have a component inside. On the outside part of it, you're going to see this located outside the house, hopefully reasonably close to the house. That it's with the monoblock unit, the closer it is to the house, the more efficient it is. So when you call the site, first of all, if you're looking at the externals, you're going to see this outside. It should be sitting on a proper plinth or secure. So more than likely it's going to be on a concrete plinth, and it's going to be slightly bigger than the unit itself. And on that plinth, because very important is that there's a drain in it, because these units do frost up, they do ice over, so there needs to be a condensed drain there to take the water. Otherwise, it's going to become a slip hazard. You'll have a wet footpath, and in winter you're going to have a frosty footpath. So you don't want to see you want to see the drain, and if the unit's working, you want to see that the water and the runoff is getting to that drain. Again, clearances. Every manufacturer will have a particular clearance, but most of them will be the minimum 250 to 300 mil from any hazards, because these units need, how they work, they need air to circulate. So it's going to be very important that they have the proper clearances and lots of free air. If it's sited at a back door, another thing to take into consideration is that there is a blow off of these. So when they're working, your air is quite cold. So the minimum distance that you can put any obstacle or anything, bins, anything else in front of it, the minimum clearance they need is a meter. So if when the house is finished and somebody comes and puts a temporary structure or something closer to the unit, closer than 1 meter, it's going to interfere with the airflows, and it's going to cause the unit not to behave properly. So it's important wherever they're sited, there's no potential for any obstacles to come into that. All right, yes.
Are they normally that size? I've seen them half that size.
We'll get to the other unit in over there. They can be literally half that. They can be twice. If in the bigger properties, this is a single fan unit. In the bigger properties, some of them can have a double fan unit. So that's.
And is that unit for a single dwelling or a house?
Single dwelling. So that's it. All right. Yes. This is the monoblock unit. So it does everything outside of the house. It generates the compressors there, and all the wet side is here. So that's when we get over to the other unit, it's half the size, because it's half of it is unit, half of it is inside. So, but with this unit, it's generating the hot water outside, and it's connected to inside with regular pipework. So it's.
That's why the distance is important.
The distance is important, because it's generating all the energy outside. It's generating the hot water to do the radiators and do the hot water for the house. So if it's part way down the garden, it's already losing lots of its efficiency. It's getting back to no matter how well you insulate the pipe, we all insulate.
How many pipes do you have? There's air to air. Is there air to water?
This is air to water. You will have exhaust air. Air to air is more commercial. It's refrigerant. This air to water is your typical heat pump. Yeah.
Just looking at the unit itself, is there any way of telling what's an air to air or air to water? You were just looking.
Yeah. No. Air to water will be the predominant. Air to air will be more or less for a commercial setting. So so the air to water is what we're going to. Is when you go to site, is what you're going to be seeing nearly in all current new housing, right? Yeah, so that's
Is it preferable to have them, say, on the ground on a plinth rather than obviously seeing someone bracket?
You'll see them bracketed. This type is really it can be done, but it is quite heavy. When we get to the other one over there, that is possible to bracket on high up on a wall. Here, we have a couple of boards made up to give you. This is linked to probably a regular cylinder, and it's linked to regular pipework. So it's water that's linking. It's not gas pipework that's linking. So it's a regular. It's a more plumber friendly system because you're hooking up pipes from the outdoor to the indoor, whereas with the other one, when we get to it, you're going to need fridge pipes, and they need an F registered contractor to do that element of it. So this one you like to see it close to the house.
What type of registered contractor?
You need to do on this one over here. You need an F-gas registered contractor or an F-gas guy to be able to link the two. One to link the outdoor to the indoor with the fridge pipe, because it's a specialised trade. It's not something that anybody can.
And what is that registered for? Refrigerated?
For refrigerated pipe, to be able to work with refrigerated gases. It's gas. It's high pressure gas. It's quite technical. The pipes have to be cleaned. Everything has to be right for it. So that's why it has to be a.
In terms of certification, would say an assigned certifier building would they have ancillary certs?
On the ancillary certs, on the commission cert, it should come up on that it has been commissioned by that the fridge has been done by an F-gas registered installer. That's where it would come into play. It's how enforced. It is an offence for anybody to work on F-gas because it's very high pressure. It's
similar to the gas regulations.
Yeah, similar to RGI. So it has the same powers, right? Yeah, because F-gas until recently would never have been in housing. It would never been an issue. So it has been introduced, right? Yeah. So that's why that's why this one is quite more bulky. It's in effect it's like an oil boiler sitting outside the house. It's doing the exact same things as the oil boiler done, but it's generating the heat in a different way. They are much more efficient. They will.
Stephen, is there a front or back to them, or does it matter?
That's the front. Yeah, the front. When we get up and look around, the back is it's not as presentable. So this is the front. Usually has the fan guard in there. You can see it. So it's generating the air. It's generating the energy by pulling the air in, going through the compressor, going through the gas cycle that's in there, and then it's blowing the chilled air it's taking all the energy off because it's going to be much colder. It's finished with it's dumping the air, and that's
so it pulls the air in at the rear.
It pulls the air in. It sends it around the circuit through the compressor, through the evaporator, and when it's finished with that element of it, it's pushing out chilled air, which is much cooler than what is. If we're pulling in 20 degrees C, or it's a nice day pulling in 20 degrees C, the temperature here could be down to. When you finish it, you commission it, everybody walks away. The last thing you think is somebody's going to put two motorbikes on it or put put
Even
anything.
now, I see with the fan guard, a lot of them didn't have that on it. So we were putting guards around them, we were putting cages around them.
Most of the manufacturers have that's protruded more than it used to, so it's harder to get sticks or fingers or kids putting. So you used to go back to service and you find a tray of stones underneath them, or it just.
That actually looks better than putting the big steel cage.
Still, it's some people, for a lot of local authority, the cage is still going in, and it just gives it an extra. It doesn't look pretty, but it gives an extra layer of protection on it. All right, yes. That's,
and is the meter completely around? It has to be a meter.
No, just a meter in front.
Meter in front.
Meter in front for the clear air to flow. It needs 250 to 300, minimum 250, a little bit more if you can, from a boundary wall or a boundary fence. And just another thing to look out for if it is your own housing stock, that if next doors is directly behind you in the next property, that it's the proper wall that's through, or it's a proper air break, because you don't want two units, which they typically are in new housing estates. One is backed onto the other, so you want a proper fence or a proper wall there. They're not trying to pull the same air into from the same areas.
How deep should a concrete plinth be? You're saying how deep should that actually be? I know it should be
just once it carries the unit. Some of these units can sit up on feet, or they can sit just once it's a little bit over the unit. It's just to give it that little.
No, that's how wide.
Just 100 mil. It lifts the unit up for snow cover or anything else. It's that little bit higher, and again with the drain in there, because if there's no drain, it is in the cold spell that we had in the end of January, February. They do condense a lot.
What are the core differences between split and monoblock?
The core difference is the monoblock is doing everything outside. It's generating the heat exchanger, the circulating pumps. Everything's located in there, and it may suit a conventional. If you're talking about retrofits, you might have just a regular size hot press. We have a cylinder here, but you can get bespoke cylinders made to suit it. So you're not changing the whole plumbing of a house. If you might be replacing an oil or gas boiler in the retrofit situation, and these may just be more practical to suit the.
So essentially, units are doing the exact same thing, but the main workings are going to be on the split system.
On the split system, this.
You have a much bigger unit internal.
You have a much bigger unit internal, but it's doing everything inside. In new builds, it's probably just a choice, more or less, whoever's specifying it. If they have a particular liking for.
Efficiency-wise, is there any difference between both systems?
Efficiency-wise, there's no difference between them, but where the efficiencies can dip is if this isn't further away, or if it's not piped properly to the inside with the proper insulated pipe work, and that's where you can lose off the efficiencies. Efficiencies with the anybody doing a paper exercise, the efficiencies will always be a little bit better with the split unit, because it's starting from the envelope of the house. You're starting totally internally. You've no heat loss, so you can generate your hot water heated nearly on direct at source. So it can it's in that reason it can come up sometimes better with efficiencies for your deep or for your so that's
Stephen, you mentioned the water runoff coming from the unit itself. Does that come out of one location, or is it just?
Some of them there is a pointed drain on it, all right, yeah. But there's that much condensation there in the unit that you can get the impression that it's coming from all over the place, especially in the very cold periods.
A drain then itself would be more an echo drain?
An echo drain, or if the base is slightly dished to a gully in the middle, it will definitely pick up everything right. Yeah, that's why. If you mentioned that, I'll get the names in later. The unit at high level, you'll have a proper tray underneath it, and a single pint of a single gully, because they do condense all over the unit, no matter what matter how you try and catch that condense in the colder periods, it's going to be a lot more runoff off it, alright, yeah. So it's.
What sort of recommended servicing?
Servicing, which will be guaranteed or will be driven by manufacturers, it's an annual service, is what they will say to continue with the warranty. For them to guarantee the warranty, all manufacturers will insist on an annual service.
So even on that, say a local authority, tenant or improved housing body,
yes,
tenant or owner, what sort of end user documentation should they have or be given?
They should get a full handover file with it. The manuals for it, whether a copy of the commission cert to say that it has been commissioned, and they should get some. But a lot of the documentation should still go to yourselves. So it's really only the user manual and possibly a copy of the commission cert to say that it has been done.
Would a lot of the documentation probably go to the design certified?
It will all go to him initially to get it signed off for it. Yeah, if it's new build, the commission cert, the warranties, everything is going to have to go to it. So again, if you're still outside, you're looking that the pipework disappears as quickly as possible. It goes down into the ground quite quickly, or enters the house straight away. You don't want to come out here and see a pipe run a couple of meters externally, because it's going to be a frost hazard, and the efficiencies are gone right out. So you want to see that it's there's connections on the back of it. There should be valves to isolate it. That when any service engineer comes, that he's not going in and turning off the whole house to two lever valves to isolate the unit. On isolating the unit, there's another thing will be an electrical isolator switch that's supposed to be wall mounted out beside the unit. That when the service company come or anybody comes to work on the unit, they know that they can fully isolate that the unit is safe to work on it, and the same on the water end, that there's a couple of valves there to to isolate it. So again, I say you want the pipework disappearing quite quickly, and you know then that and tidily with the valves on it, the electrical switch. So after that, it's sending the water into the house when it's heating the hot water element of the house, it's going to be at 50 degrees, 52 degrees. When it's in hot water mode, heating, it can be less. It can be probably max 45, right down to 30 degrees. Which so it's sending the hot water in via pipework, and it's arriving then at this. When you move from outside, you're going to the inside of the house, you're going to be met with something like this. Different manufacturers will have slightly different. It mightn't be as tall. This is a cylinder buffer, so which means it's 2/3 stored hot water for domestic use, for your taps, your baths, everything else, and 1/3 is for the heating system. It's a buffer and a heating system that allows the heat pump to run more efficiently. Because
Stephen, could I just ask you to maybe recap on if you were looking at it visually?
Yes.
So you want the 1 meter clearance to the front, the isolation valve. That sort of thing. That's
you look general tidies. You're looking to see the unit secured, yeah. Hopefully on a base. Hopefully there's a drain there. It can be gravel, it can be stone, but it has to be that the water is not running off and being a hazard. You're looking for isolators, yeah, on the water. There's two water connections. You're looking for those to be there. You're looking for the pipework to be properly lagged, and hopefully going out of sight fairly quickly, either straight into the property or down into the ground. And you're also looking for an electrical isolator that will be here to turn off all the power to it. That's only for the. You mentioned the cages earlier on. That's when the cages come into place. There has been cases where somebody comes out and turns off the isolator. So if for a lot of local authority housing still has the cage, the isolator will be inside the cage as well. That it can't be that can't be messed with.
And then of course the drip.
The drip, yeah, that's so that's really what you're going to see. The meter clearance. You're hoping that somebody hasn't set a patio area, hasn't set any obstacles in front of them by the time you see it. That's
some of these companies actually lower legs.
Rubber feet, which will lift them up again.
When you put them all together, about 152 and off.
Off the ground, yeah. That's so you wouldn't need the concrete plinth, but you still need the space, and you still need the drain.
Someone comes with the drip tray, and put the gully underneath the drip tray.
Gully underneath the drip tray, and you'll pipe into it, right? Yeah. So that's so you want that again. You want that drain close, because if it's the other end of the unit, you're trying to pipe that, so that's a condense, and if it freezes, then it can bung right up into the unit, and you have a.
So if you've got the rubber feet, you don't need 150.
You don't need the plinth, but you definitely still need the drainer, right? Yeah. So that's it.
Stephen, are there any common signs for installation of the external unit?
The common signs that is not.
What are your common problems that you've come across?
The common problems that it's located too far away from the house, and the pipework is visible, that it's not secured, because even though it's heavy, you still need it fixed down some way.
Did you say located too far from the house?
If it's located too far away from the house, and your pipework is running a distance back in, that would be.
And does that affect the efficiency of the unit?
It affects the efficiency by the time it gets into the house. The unit's working away. It doesn't know that it's any further away from the house. It's working away to its best efficiency, but you're not delivering the end product, which is the energy.
What sort of distance would you have in mind as being too far, or where is the?
For this type of unit, any more than 3 meters from the house is really getting. But it depends. You've got to know where this is inside in the house. Yeah. The max run that there should be between this guy and that guy is 15 meters of pipework. Any more, it's starting to tail off, and it's.
And is that's a portion to where it is in the house?
The portion. Yes, it shouldn't go over 15 for this type of unit. We have more scope with the split unit.
You have a massive big house out in the car, and you stick this just on the house, and your boiler or your unit is up on the third floor,
yeah.
And it's 17 metres away.
It's 20 metres or 22 metres.
Yeah, so it's critical the location within the house as well.
The design of it, yeah, that it's as close as possible to the.
70 metres of pipework rather than 70.
Yeah, it's 70 metres of pipework. Yes, 70 metres of pipework. Right. Yes, that's it. Yes, it's not the physical distance. It's how you link one to the other. So you have to take the rise and that.
This is the unit that comes. That's the pipework already fixed by the manufacturers.
Yes, a lot of manufacturers are trying to sell everything to take the risk out of the installs. Are trying to package their own outdoor with their indoor element of it. So it's just because they have to guarantee flow rates and everything's going to work properly. Inside this unit, we have a coil that goes around. So they have to know exactly how long that coil is to tell them how long it's going to take to heat their hot water. So that's why it's mix and matching doesn't really go with the manufacturers or with the units. So. Yeah, that's it. I can do this just on the mix and on the matching. Before this, plumber yourselves, anybody go in, you buy your gas boiler and you mount it. You didn't have to worry as much. You know what cylinder you're going to put in. It's going to be a 180 litre cylinder. It's going to store the water. But with what we've moved on to with the heat pumps, the manufacturer has to know from his outdoor unit. He has to know exactly what he's delivering to. So that's it. You've got your outdoor unit, your pipe. We're linking up to your hot water's been delivered into here. When this arrives out on site, the plumber has two connections from the outdoor to the indoor. So he's one here is flow, and down here is his return. So the unit's hooked up, and as the controller as he starts to commission it, everything's filled up. All heat pumps like to heat the hot water, domestic hot water first. They bring that up to a slightly higher temperature than what their central heating water would be. So there's a 3-port valve here, and that will determine whether the heated water coming from here goes to the domestic hot water or goes to a stored buffer and in turn off to your central heating. So that's.
Sorry, Stephen, just the main supply should be directed connected directly to the public main, or should it be?
No, this is going to be coming off it will be fed from mains water. It won't be coming from a storage tank, which again in local authority housing you were used to have maybe your small cistern up in the attic, an open vented system. That is more or less gone by the wayside because they need a minimum pressure to work on, which is another maintenance issue. The system has to be maintained at a pressure, or they will shut down on.
So in a new development, new houses, what would you see? And then in the local authority retrofit scenario, what would you see?
In the local authority retrofit, you're still trying to keep the plumbing and the house as much intact as you can. You don't want to start going in and ripping out. You will have to replace the cylinder in the hot press, but you don't want to start into boosting pipe work that's there. We don't know how long it's there, so the last thing you want to do is that. So you will come up with it. The manufacturer have solutions that to leave the system alone, but they're more bespoke systems. They're designed specifically to replace like for like. But in the newer housing, you're going to be seeing something like this, and this will only really work on a boosted water, which is going to be your cold storage in the tank in the attic, and a pump somewhere in the house to boost it.
Just on that, in the retrofit, it's not just local authority. Remember the new Cardell, if you have a major renovation, you're going to have to comply with the new building regulations. That's where we're going to retrofit for anybody that's putting on a major extension there. You're going to get caught with that, and that's where you have to have, especially the thing with the water main connection, because they would normally think, oh, you just tap it in from the storage tank that I listed and have. That's gone now. So with major renovations, the new regulations, this is applicable to it, whether it's retrofit for local authorities or for the common private dwelling outside.
Okay.
Yeah, so it's not just local authority, as John says. Yeah, you're going to be coming across it in more retrofits, all right. Yeah, but in any new stock that you go at it, it's going to be something like this, for the indoor part, and it's going to come from the same manufacturer as the heat pump. These cylinders they won't deliver the same pressure. There's more items on them. They're going to kill the water pressure. So if you're depending on gravity feed to drive the hot water, it's going to kill the pressure. So you're going to need something to boost it. And as same, when this unit comes out, or other manufacturers, they're going to be a lot of them are set up already for the pump. So that's this has a pressure release valve on it here. That's ready for a pump to be just clicked, more or less connected straight up to it, and gives you the hot water. So, but that's on the domestic side. What the heat pump is doing, and they will all do it. The homeowners get very used to it after a while. There's no more setting timers for hot water or immersions. You have constant hot water more or less from these once they're set up properly from these units. So they will always look to heat the hot water first, and when the hot water demand is satisfied, they will divert. Doesn't necessarily have to be a buffer, but it will divert to go to the radiator system. So, but.
And in terms of where you would see it in a house, for example, should it typically be in a utility room, or not necessarily?
They're a white goods finish. They can be quite exposed. They can be. That particular unit, when the cover's on it, it can sit. You won't really know what it is if the utility room is big enough.
There's probably no carbon monoxide.
There's absolutely no. There's not. No.
Maybe a smoke detector would be.
You already have your smoke detectors in the house anyway. There's no additional regs for anything. You've no carbon monoxide possibility off the market. So that's so they can sit quite easily in an utility area. Something with a lot more pipe work. You like to have it in a traditional hot press. The only thing, they are quite bulky, so they do need more space. So that's and again, no different than gas or oil. You have this, but you still need to, for building control, building regs, we still need to zone the heating system. So you're going to see more than that. You're going to see something like these arrangements down here. You still have your motorized valves for zoning. You may have an additional expansion vessel. So there is a bit of space needed.
Can you explain to me what you mean by zone heating?
For as building regs gone back a number of years, we have to split the bedroom area when the house is over 100 square meters, it has to be, and it's good practice probably to do it even in smaller houses. The living zone can be set at has to be mechanically separated from the bedroom zone. So you have to be able to put a temperature control in your living area, which is usually your downstairs area, and a separate temperature control in your bedroom area. So.
And if I was an end user, what would I expect to be shown in terms of how do I know it's not working, or is there something I should do in an emergency? Or
yeah, that's all the units will have themselves will have a display either mounted on the unit, or it can be mounted in the hot press or outside a utility room. It can be mounted somewhere, but they're still going to have temperature control, and hopefully most at this stage we're nearly all gone to digital temperature control. So your ambient temperature is going to be 21 for your living areas. It's going to be 18. It's designed for 18 for your bedroom areas. Most people will still look for a little higher. If their temperatures start to dip off and the house isn't maintaining temperature, then there's something wrong with the system. There will be alarms on this that if it's low pressure, if the flow rates haven't been achieved, which is usually flow rates is usually down to the system filters getting clogged up, or it's due as time for a service. But the end user will probably their digital wall stats should give them an indication that if the house started dipping to 17, 18 degrees in the living areas, there's some reason for it. If it's a new house and it's airtight and it's up to regs, there's something wrong. If it was working fine and now all of a sudden it's not generating the proper room temperatures, there's something going on somewhere that's curtailing that. And again, their hot water should be more or less on demand. So if they notice that their hot water it's not lasting as long, it's not getting up to temperature, there's something going on with that. That's a system filter, a Magnalene. Again, there's lots of different manufacturers. Some manufacturers will insist on it being on for warranty because it does pick up particles that's in the waters. Some manufacturers will actually insist on it being in place because hard water. If it's a radiator system and you're heating regular radiators over years, no matter how much inhibitor we put in the system or many, particles can come off the radiator. So that is a filter.
Show us the internal components then.
Off the.
If people want to come and have a closer look or whatever.
Yeah, no, anybody can. Yeah, anybody can.
You know.
That is the filter. Again, it's not mandatory. It's just good practice.
Yeah.
So
sometimes when you're inspecting, you actually see that right behind this unit. It look good, but you won't be able to get to it.
Yeah, it needs to be right. Accessible. It probably won't be outside. It's going to be probably the first thing that you see inside in the hoppers.
Just on systems where you have radiators or where you have underfloor heating, or
it's more practical. If you have an underfloor system, you don't have very many metal components. Okay. So it's a good practice to put in. Regardless, every system has some metal components, so it's over years when they start to degrade a little bit. That's a magnetic filter, so it attracts all the residue.
Following on that, it's white PVC here. Should the colour of the pipe, is that important, or should it be blue, the way you see in one?
No, look, this is just one particular manufacturer. In it, that's their lagging is blue. The pipe is most of these pipes are all what they call alu-pex. Yeah. There's lots of different manufacturers. The pipe can be white, it can be grey, and they will come with different manufacturers have different colour of insulation on it.
And again, that's just ideally that should be visible, but
ideally it should be visible more than likely in close to where that is, right? Yeah, you can't insist on it if the manufacturer doesn't insist on their warranty. If you're doing a site visit, you probably can't pull somebody up that is not in place already, because different manufacturers will look for it. This particular manufacturer, it's part of their warranty. If they come in and it's not there, they'll nearly void the warranty because they see it as being an integral part of protecting the system. The system will have other filters in there that will be cleaned on service, but it's to stop as much residue getting to those filters as possible, right? Yeah, and retrofits it'd be a given.
Is the inhibitor used the same as a conventional heating system? Or
yes, no, it's dosed. Yeah, once the system is dosed to regular.
Okay.
So, some manufacturers will look for, because this unit has a potential, there is items in here, some will look for an antifreeze to go into it. But again, that's going to be down to the manufacturer. If they insist on of a glycol going into the water to protect the components, then that's their prerogative to insist on that. Or yeah, that's some manufacturers don't like it. Glycol's a glycol. There is a residue on it. And it's something else that has to be, the end user then needs to know that there's glycol added, and then if the service time, it needs to be topped up again with the glycol, or it's just like your antifreeze in the car. It has to be replaced from time to time. So that's it. So that's the other components you talked about, the tank, or not being a tank. The system has to be filled, and it's usually going to be filled from either the boosted cold water or from the if bylaws allow it, the incoming water main. So that's the top end of this on this particular unit is all to do with the central heating system. So it's been fed in here from the heat pump. It heats up roughly a third of the unit, probably 60 litres of stored water. The buffer serves as a couple of different things. It gives a little bit of stored heating water there for when the demand comes on, and it also allows the unit to constantly, because these units don't like to stop and start. They can break down after a number of years if they're constantly stopping and starting. So with the buffer, it allows the unit to run and keep dumping into this unit, even if there's no demand in the house. The radiators, the rooms are hot enough. You don't want heating, so it allows the unit to keep circulating a little bit through the house. There is other ways of doing it with a bypass valve, but for the moment, this one we're looking at. So it's heated hot water. We're now at the top. This is off to the heating system, to the radiators, to an underflow manifold, whichever. It's after this area where your zoning comes into place, where you have to zone your living area and your bedrooms. So that's simply that. Some of them will have, you might see an immersion here for a backup immersion if the heat pump isn't performing or isn't there extremely cold weather, that they have the facility to bring in immersion. So we move on down. As I said, this is the 3-port valve, and this determines where the water goes to, whether it goes to the heating or goes to hot water. After that, this particular unit has a bypass here, that if something fails here with this unit, or something that the unit doesn't go into fault straight away, that it can keep the bypass will allow it to keep circulating. Over here we have a safety feature, and that's a safety valve for the stored hot water, that if something happens, if this immersion goes crazy or something, that it overheats, that it has the facility to release and let it go. So it's a temperature and pressure release valve, so that if something goes wrong with the pressure, it releases, or something goes wrong with the temperature, it releases. That feeds down to, as we see, to a tonnage here. This needs to be piped to external. So that is one safety feature with this, because we're now pumping this system, so it has the potential to release a lot of water very quickly if that is not piped to outside. So it really needs to be piped outside.
That's why sometimes you see a 50 mil pipe.
Yeah, it can be copper, preferably copper, or a proper pipe. It has to be piped that can actually take a pressure. It can't be low down. Yeah, you don't want it coming out straight from that. If the hop back at the house and down at low level, because that could, yeah, down at footpath level, and maybe even turn down then again when it comes out. Because that water, when it blows off, you don't know how hot it is, or what. It only fails for a reason. So if it fails because that water's got too hot, it could be over 90 degrees water coming down. So you want it coming down somewhere where it's gone straight away. So that's
just on that. Say if you're a building control officer or local authority official, housing, or from another department.
Yeah.
If you wanted to witness the commissioning of the system,
you could actually, you can force a blow off on that. Right. You can just flick it. It'll just that pressure release valve So you'll see it working through the tundish, and you should be able to see where it goes to outside. Because you don't want a pipe just disappearing into the floor. And
when you look at that gauge, what would you expect to see?
This gauge here is the heating system, so we're going to be between 1 and 2 bar, so about 1.5 bar usually on that. We're not looking at these systems. The stored hot water will determine on the pump that's feeding it. So usually a 2 or a 3 bar pump. This safety guy here is supposed to throttle the pressure down to a max 3 or 3.5. This one's actually 4.5 bar, which is.
So what's the significance of the red there?
Why
is that red and the other one is grey?
This just
it's a safety feature.
Safety feature, just to know that it's there. Again, you could force a bypass or a blow off there to see. It is a safety feature for if the pump goes crazy on the way in, or if a lot of these, if we were in the UK, you'd have mains pressure maybe of 4 and 5 bar come in. We don't have that on most of our.
And I assume it would be recommended that you get the installer to force the blow out. It wouldn't be the local authority.
No, it wouldn't be. No.
But if you just wanted to witness it.
Yeah, if you came in when it was just been handed over else, and if you couldn't see a pipe outside, or you can see, well, what happens if this blows off, so then you could ask for it to be demonstrated, right? Yeah. So this guy here will protect the cylinder and the system. If the incoming pressure is too much, so with us in Ireland, it's usually just going to be a booster pump to get us up to that pressure. It will facilitate a blow off if the pressure goes too high on that. So that's going to be cold water, which isn't a risk. This guy here, as I say, is a pressure and temperature release valve. So it'll release on pressure, but it'll also release on temperature. So that could be quite hot water. Again, it's rarely do they blow off, but you have to have them. You have to leave the facility that it can get away safely. So that's why, as you said, that you wouldn't need a pipe going out. Preferably a pipe that can take high temperature, and it should be piped to low outside. That's that.
If you see water coming out that safety valve, that overflow we call it, is that always indicative that there's a problem?
There's a problem. Yeah. No. It'll never come out there. It never should come out there unless there's.
And what if the system is generating hot water, but it's not being used? If it's creating more than it's using, what happens? Where does the expansion vessel? Or?
Yeah, there will be an expansion vessel. There's an expansion vessel for a safety feature, and there has to be an expansion vessel. There has to be an expansion vessel quite close by it. That's to allow to. Because when this cylinder's coal is sitting at 14, 15 degrees water, so hot water naturally expands. So you have to have a facility there for it. So that's.
You usually see 2 expansion vessels.
You'll see 2, one for the heating, and one for the water.
So you have to see, make sure for a system like this, one thing to check is that there is 2 expansion vessels.
There is this. If this water's been boosted, which most generally will with the pump, has to have an expansion on it. It'll usually these valves, and this is the point that it usually would be at. They have a facility to screw in there. You don't want to see the expansion vessel being too far away from the unit, because it's a dead leg as such. So you don't want to. You want it quite close. There is a ROS guideline, and it's 600 mil from the unit to the expansion vessel.
Yeah, but I think when we were cycling time, it was over a metre.
It was piped. Yeah,
you piped it up around because you couldn't get in.
Just for tidings, to try and make it tidy, and again it dipped down. You want your expansion vessel mounted reasonably high. It shouldn't be mounted horizontally. It should be mounted that it can drain whenever the water is drained. That you're not creating a dead leg by having either a loop and a hose or down here, because then it's a complete dead leg. There's never going to.
It should have always for that should always be higher.
It should always be higher. Yeah.
Double valve there.
It can be any colour. It can be, But more often than not, as if we read on a white one, fresh water, there's a difference in the vessels. The fresh water will usually be white or blue.
Okay.
Most of them, the red ones, are designed for the heating system, which is a different diaphragm inside. So it's a.
And is there a built-in expansion vessel in this unit?
No, that unit still needs all these components. It still needs. If you get to a utility room and you see the nice tidy unit there and you see the front on it, it still has to have the expansion vessel located somewhere. So with that, you're still going to have to have a valve somewhere like this, and you're still going to have the expansion vessel, and you're still going to need the blow-off. That unit will have a blow-off point inside, and this valve here will have a blow-off point. So you're.
Is there a circulating pump built into them, or is the circulating pump separate as
No,
well?
there's a circulating pump built into. Both systems. Not this one will look, as I said, it'll look a lot tidier. It'll fit in, but it still needs the extra components. It's still they're heavy units. Yeah, no, they are. So that's. Is it practical to have them upstairs? It's.
Well, even upstairs in houses, there's designs upstairs in houses, and that's reinforced for us. Extra.
Yeah, well, that's when you put the two water tanks that reinforce.
Yeah, no, that's.
Those little things you don't think about.
The reinforced settings at the back and check out reinforced.
Yeah, well, for a start, you're going to have over 200, maybe some of these are 260 litres stored water. So you have that weight, and then the components on top of it, so they are.
Three lads to lift them up. How you be kind of 3 lads had to lift them up the stairs.
Yeah, no, they're
and they were empty.
Well,
Yeah.
you don't have a system that doesn't necessarily, when you have the heat pump system like that with the monoblock, a plumber can fabricate that all himself.
If a plumber can fabricate, it doesn't have to come with all the components. This could be two items. You could take away the top half and have it somewhere else. It still has to be under the manufacturer's guidelines that they're happy with the particular.
I think in the total, you would actually see there's 2 tanks.
2 tanks.
And they had a whole spaghetti junction of pipe with the plumber thing.
Yeah, everything can be linked up. These, what they call the Preplum units, they come like that from the manufacturer. You can get them without all that stuff and do it, or you can have it. You can have 2 tanks. Just take one away.
But those items you're going to shoot, they're the key points.
They're going to be in any system. You have to have your safety points on it, and you have to see the discharge going to external. Apartments, because you can't get to external, it can go to drain, but it has to be properly trapped, and you're still going to need a tonnage on it to see that it can be a.
So if you were to say, or could you say, what are the top 3 or 5 things to look at?
The top 3 is the tidiness of the pipe we're coming into it.
Yeah.
That we have the safety features. If we have a booster pump in the house, to make sure that we have the safety features, which is the split valve for the hot and with cold water inlet is split into the hot water and split into the cold water in the house.
So if I wanted to recognise that safety feature, could I say, well, how do I recognise it, or is it the red cap on it, or?
You'll see that it's quite bulky. It'll have 3 pipes coming into it.
Okay.
One feeding in. It may not be sitting nice and tidy like that. It could be located somewhere else if it's not a similar unit. But it's going to have something to regulate the pressure going to the house, because that's these cylinders are not meant to have any more than this one says 4.5. That's the max you can have going in there. If a pump, something happens to a pump and it starts running continuously or generating more pressure than it's meant to, then the potential, if that wasn't there, you have the potential to start. These are stainless steel, they're quite sturdy, but if you're dealing with heated water, and if the immersion has been on, it could be 60, 70 degrees, so you have quite a pressure in there. So you're going to need to see that we have the pressure release facility there to blow off.
Okay, and then
and you usually have 2 of them. You have one on the inlet coming in, one on the outlet to take the hot water. Moving on to that, you want to see that there's a proper fill on the heating system, like we have here. Something that can be isolated. These can actually be taken away and capped, but for the end user, that if their heating goes down, one of the most common things is the pressure of the heating system has dipped after a number, especially if the unit hasn't been serviced. You're going over a year, you're going to have an evaporation in the system. So you can talk somebody over the phone, if it would be a tenant, whether it be a homeowner, whatever else. What's the pressure here? If it's not reading properly, you can direct them to turn on these 2 valves and isolate that. So that's.
How do you have the Fillin Loops?
The immersion has 2 functions. In this particular thing, it's usually all controlled from the same. I'll pick one up from the same controller, Ina. It's controlled from the heat pump. It won't have an external control. It won't have your ordinary what we had in the big sink bath switch. It won't have that. But it's there to as a backup, first of all, to the immersion, to the heat pump. And the second thing is there is because we're heating hot water to max 52 degrees. At that temperature for prolonged periods, there is a chance of Legionnaires. Slight, but there is a chance that it will start growing on the inside the cylinder, and if that grows in there, then you have a potential. You have a big hazard. So what most systems will do, they have the immersion here. It will be set on the programmer to bring on that immersion usually once a week at same time every week.
If I was looking at that, how would I know it's connected to the immersion?
To the heat pump.
To the heat pump.
If you walked in the hot press and you see no obvious switches for an immersion, you don't see your on off, you don't see your sink bath, you'll know that it's an integral part of the heat pump. So
was it reasonable to say where you are installing in a new development or a retrofit, you shouldn't see the on-off for the immersion switch? No, I know we've worked in some houses and the clerk of works came in and he said it was part of their reg to have it they still wanted to have the immersion as a backup, but we had to explain it's just not possible to. Can you just explain what those 3 components are?
Yeah, so we've moved on from the blow-off valves. We now have the Fillin Loop, and as you said, it can be either left connected, or a lot of times it has the potential to cause a lot of harm to the heating system if it's left on. So sometimes it can be capped. After that, more or less, the immersion, as we talked on there, that's going to be controlled by the heat pump, and that's for the Legionnaires.
So what are you pointing to there?
That is the physical immersion that's in there. That's the usually.
That's another sign that I might know that it's connected.
It's connected. Yeah. You'll physically see it in these units. Those units, when you get them, you won't. These you'll physically see it. So that's going to be wired directly back to the heat pump. You see, you're not going to see the switches. This here is actually defunct on this because we're controlling everything from our controller. So that's just a terminus that it won't be wired up.
Is this an
that's
or what?
This is connected to the blow-off point. So you can physically see here if some of these go and start passing that there's something wrong. You'll see the water. They like to have a tonnage on it. It's a little bit of a hazard. It can splash a little bit there, but we're going to be piped from here directly to outside in either copper or pipework that can take high temperatures. So if somebody goes up to the hot press and they see something wet, or they see the floor is wet, or you usually will hear something going on.
And so just before we move on, sometimes building control has a role in construction product regulations, market surveillance, and energy performance. So can you explain to me what I should see there and where I get a CE marking on it?
You're going to see. You hopefully will see a manufacturer on it.
Yeah.
You'll see a brand name. Every appliance now has to have its band for its rating.
And are they all rated the same?
They'll have this in C rating. Some will be. You wouldn't like to see much less than C. Some will be D. It's hard to get a product that will have an A rating. This is nearly impossible, right, Jess?
There's no harmonized standard for plumbing.
No.
There's a C mark.
There's
no harmonized standard.
The literature that comes with it, was that's handed into yourselves or wherever else, or handed to The end
There is
user.
a CE marking on the cylinder at the rear.
On its yeah, you have the badge, it'll have a serial number, and the serial number will, as part of commissioning, that serial number will be logged with the unit. And as compliance, it will have to have a CE mark. You'll have to know where it's manufactured. This is what the split system. Again, the principles of the outdoor is going to be the same. It's going to be either located on a base, on legs, with a gully close by. Clearances are going to be the same because it's doing the very same job as the other unit. So you're going to look for minimum clearances, 250, 300 mil from any to the side and to the back of it. And again, you don't want any hazards parked in front of it for that it can blow away its clear air. This gives you probably gives you more flexibility in the location of the outdoor unit. You can run slightly longer distances because it's been linked to the indoor with a fridge pipe, which is a very small bore. It's gases at very high pressures and high temperatures when they get to the indoor. So it does leave a little bit more flexibility. It's lighter, it's smaller. It can be mounted at high level. And once, if it's mounted high level, it will have a tray underneath and a particular drain, and it'll be pipe to drain. So it does give more options. It can be used on a apartment block balconies. Sometimes you will see them on them. Not that common in Ireland, but other countries would be very popular for air conditioning units. But they can be mounted on in a balcony setting. So they're just a lot more flexible because of the weight and the size compared to the other unit. So again, outside you're looking for the electrical isolator and fridge pipework. Again, should be disappearing quite. You shouldn't see much exposed pipework. If it's a little bit distance away if you come out to a site and you find that it's 5-6 meters away from the house, you just have to know how that pipework gets back into the house. It should be located in a duct, and that duct needs to be watertight, it should be sealed where it rises up to the outdoor unit, and then inside it's going to be naturally sealed anyway where it's up above any water table. But
sorry, so the pipe work from the monoblock to the unit that's on the monoblock is not a duct on a duct. This one has to be a duct.
The other one can be linked to it. It's insulated pipe. It can be your chunky underground insulated pipe, or it can be regular insulated pipe popping just in through the wall. This one has quite small fridge pipe linking into inside, so it'll come just coated copper, but it has to transcend inside somewhere or other. You want to protect it because first of all it's gas. So you can't just lay it in a bit of soil and hope that it gets in. It has to be to a proper depth. It has to be protected. And for the efficiencies and for the unit to work properly, it can't be just sitting in soil and sitting in water. It's gas pipe, and it'll shorten the life of the unit by a long time. The unit's going to be the compressor's going to be revving up to try and deliver a lot more than it should be. So
And Stephen, because it's a gas pipe in the sleeves, you're saying to make it watertight. You don't have to vent it at the same time because it's a gas pipe in a sleeve.
No, it's a continuous gas. It's not. We're outside, or if it's leading to inside, it's not. It's going to be airtight, but it's not going to necessarily be.
Usually on the gas pipe, there's no joint.
No, there should be no. It should be a switch. Yeah, one unit. Yeah, correct. It should link. The preparation is probably more crucial with this. It's crucial with everything, but it is crucial that when the builder's starting his house or whatever else, that he's allowed how he's getting the fridge pipes from this unit here to the outdoor. So a bit of thought should have gone into where it's into the ducts, getting those at. So
and will that duct typically contain the gas pipe and any, let's say, electrical?
No, electrical would be separate, because the electrics running from one to the other, they're multi-core. They have some communication cables in there, and they can be quite sensitive. So you wouldn't run the electrics with the pipe work. You'd run the electrics. You need a proper underground. Yeah, proper underground cable or in a duct. So
Do you have to refill the gas at all? Or
that will be, again, not in nearly in the lifetime. You shouldn't have to.
so what is the lifetime of
The typical, look, they'll tell you 12 to 15 years should be a typical. It's the gas levels will be picked up if they've been serviced properly. The gas levels will be picked up. It can evaporate a little time if the unit has been working maybe out of sync and over gassing. It can lose gas, but not it shouldn't be happening in the short term. So that's so the duct is crucial because say if the pipes were just dropped in the soil and it's going to be using up the energy there to try and deliver into the outdoor jet. So that'd be one thing to look for when you get to the outside. It can be located a little bit further away from the house because the gas is it's not like we're losing the energy straight away because the compressor's working to inside and it's inside is starting to generate, but within reason. We can't send it off down to out of sight down the back garden completely, or it has to be there will be probably a 20 metre max between the outdoor and the indoor unit, or otherwise efficiency start tailing off. The connections on that gas pipework have to be done by an F-gas registered engineer. There's no substitute. Somebody can't just take out a couple of bottles out of the back of the van and start into it. It has to be F-gas. They come pre-charged, so if the unit is less than 10 metres from between the two of them, the unit will have enough gas to do that. The pre-charge will cover up to 10 metres pipework usually. After that is where the F-gas engineer comes really into play. He has to weigh the gas and add gas to the extra length of pipe. Yeah, a plumbing contractor. Yeah, you can go off and get trained up to be an F-gas installer. Yeah, where does the gas line come in? The gas connections, when we get up, we'll see it'll come in on the right here on the right hand side. There's the actual cover there. That's again, most connections in everybody's unit is to the right hand side. We've done our connections. You're happy with everything outside. It's again linked into the indoor unit. Now these they are quite heavy. So if it's a 2-story property, you'd love to see them downstairs in a utility room. And again, it's two benefits. It's the weight on your floor, and again it's close. It's probably going to end up being closer to the outdoor unit. So your runs of pipe is you're meeting a couple of different things. With the closer they can have them, the better, right? Yes.
So if you were a building control officer or local authority official from housing, how would you satisfy yourself that that's being corrected, considering you may not know exactly what you're looking at?
If you went out and you seen something like that, and you see the whole footpath the plinth is soaking, the footpath soaking, there's something wrong. The base is improper. It isn't incorrectly. The fall isn't going to the drain, and the drain's not big enough to catch the.
And is there any paperwork that you could look for to?
It's nearly going to be site. No, there's specific paperwork. There's a general good code of practice which will be supplied to the installer. He will have received his design for the unit to where to site it. He's probably working on a drawing where to site it. So all that should be in place. But there's a specific paperwork or a specific tick sheet. We are handing out a note later on that just give general things to look for. But it's going to be more visual. First of all, you're going to see that it's not put up against the fence. It's not put up tight to a wall or shoved into a corner, because then it's just not going to have its.
So if you're looking at a development and it's at various stages of construction, and perhaps the unit hasn't arrived on site.
Yeah.
They should make allowances for the plinth, for the drainage.
For the drainage, yeah. That's it. That's it.
Some of them drip trays, the actual outlet on the drip trays to one side, and some of them in the middle.
Some of them, yeah. So that's. But if there's a gully there at all, you can work to it, right? And that the plinth is dished, right? Yeah. So it's no. If you call out, they should be making arrangements for their ducts. How they're getting into the property. The ducts should be in place from an early stage. So.
In relation to the internal units, suppose from a fitting it within an existing hot press or cupboard or freestanding, whatever it is, service access down the line, is that purely needed?
There's a minimum clearance because you don't want to butt it up against the wall or another press just for simply vibrating and night. But everything can be maintained from the front, right? Yeah, you're getting right into the front, so that's all you need in it. So has to be.
Key things with the expansion vessel again. One is the 600.
Wherever. It shouldn't be more than 600 mil away from this unit.
And what about the height then?
Height, once it's above the unit, and again, that there's no lag in the hose. That the hose doesn't dip.
So in terms of that unit over there, it has to be higher. You're looking for it to be on top of the cylinder. Yeah, that's you don't want to come and find it in the press next door and down here, because it's just not. It's going to be too far. It's going to be too far away from the unit, and it's a complete dead leg. That water can above the unit. That at least anytime the water is turned off for maintenance or anything else, that leg drains down and it's gone. If we mount a freshwater pressure vessel down at floor level here, that water may doesn't. Water will only flow one way. It's a ROS regulation. Here we don't have in other countries. You have to have a special ticket to put in the pressurized system. We still don't have it here. It probably will come in as a. You mentioned ROS before. What is that?
Look, it's a UK reg, but most freshwater most systems here are designed. It is recognised here. Whether it may have changed since Brexit, I'm not sure on that one, but it's what all potable water products would be registered to or would be designed to ROS regulations. We don't have a direct regulation here to replicate it. Irish Water are probably working with something that we probably will have in time or yet, but currently, as far as I know, could be corrected. It has been the guide for most products to be installed to.
And that's where the Legionnaires.
That's where the that's where the Legionnaires would come from. And that's where the likes of the pressure vessel would come from. Or it would be a.
But it would be your recommendation.
It would.
Housing and other officials
to not.
Sure it's above.
Above, yeah, because it's potable water. We don't know what can grow in that down there. If it's a dead leg that's never going to get out of there. So you just want it. It's good practice. You don't want to. You don't want to encourage it if you can, right? So that's why when most of these are supplied, they will come with they'll come with usually with a hose, and that's not going to be very long. So that's what they're designed for, is to be mounted quite close to the unit, not piped into another room or completely away from where the unit is. So.
Like you mentioned, like it's potentially a Legionnaire's risk, so you could look for demonstration under Part 3 hygiene and the building regulations.
Yeah, that's demonstrate that it's not going to be, and then really then there's no way they can't demonstrate. There's not, because nobody knows what's going to grow in a dead leg of pipe right over. You're probably talking over a long period of time, but it's a risk that can be. So as I say, you're going to see the nice tidy unit that's fronted up, but somewhere after that you're still going to look for the pressure vessels have to be there somewhere. Again, you're more likely going to come across, still going to have to zone your heating. So that's again your motorized valves, your temperature control in your living area, your bedroom area. So again, somewhere in the house that has to be in play. Heat pump, all heat pump manufacturers would love if we didn't have building zoning. It gives them more scope, the flow rates to achieve everything. But your building regs still dictate that we need to zone the heating systems, as whether it doesn't matter whether it's gas, oil, or whatever the heat source is. So that's.
You mentioned the SEI database.
HARP database. Any product, if you walk out into a site and you see a name that is not familiar, you've never come across it before, it could be quite popular, but just you're not familiar with it. You can check with the SAI. Every heat pump that's brought in has to be registered with them and registered on their with further efficiencies on the HARP database. That would be the go-to for any product. Every manufacturer has to bring it in, get it approved, and get their efficiencies up there on it. So that's.
So if the name isn't on the list, it doesn't get in.
It's probably it shouldn't be in. Yeah, that's. It could be. Look, you can't. It could be in the process of being on it, and that maybe hasn't been updated on it. Maybe all registered. Maybe somebody just hasn't uploaded it. But you can go and. It is a point of reference to see that it's a reputable brand, and it is given the particular efficiency. So
you mentioned the control unit. Is there? Does it matter where that's located, and should there be anything located aside from an electrical installation point of view, a fuse or a switch or anything?
It'll be fused within the unit. No, it can be mounted. It can be a thermostat, same as a thermostat on the wall.
If it's mounted on the built-in unit, that's fine.
That's fine. Leave it.
If it's not.
If it's not, it's still usually in the room where the where the controller is. It can be located. It really can be located anywhere. Yeah, as I said, this is one of the manufacturers of a common install in apartment blocks. It's typically this is what the heat pump is. It's a combination of both of those that we were looking at earlier on. So it's generating it's a smaller unit, but again it has a smaller output. So it's only really going to be for apartments. It's the basis of it. Instead of getting its energy from outside and outside air, it's now pulling the air from inside the apartment. So from your wet areas, from your bathrooms, and your kitchen, it will extract. So you're meeting the unit is now meeting its regs with ventilation, because it'll be commissioned to give you 13 litres for a kitchen, your 8 litres for 8 litres per second from a bathroom.
So where would that be? What part of the house would that be installed in?
This will be in your plant room hot press. So this unit will literally sit mounted to the wall over this.
Okay. So the hot press door is closed.
Hot press closed doors, yeah.
Certainly has a shower or kitchen, so that's expecting the vapor, steam or whatever.
It's pulling from the wet areas in the.
Pull up even when the hot press door is closed.
Oh yeah, no, it's totally it's pulling from the apartment, from the.
That's running 24 hours a day.
Running non-stop. So it's running non-stop at that element, whether you need hot water or whether you need heating in the apartment. So that's.
So it's going through the ducts.
Ducts, yeah. Within the seal and void, it'll have it can be your flat. Typically, it's going to be a flat pack ducting, or around semi-rigid.
So that kicks in for regs there, lads. That means there's a false seal. So anything that penetrates that has to have a fire column. So you've got to be watching out for that.
Yeah, your duct where it comes down through the ceiling. That's
But yeah, anywhere where there's a false ceiling, even in a house where you have engineering joists, that's considered suspended ceiling. So everything has to have a fire collar that penetrates through it. So especially in apartment blocks, you're going to have a concrete floor preferably that's sealed. Then you're going to have a false ceiling for this duct to go through. And that's all purposely from the wet rooms is going to feed into this here. So you're going to have to check the fire breaks all along that there where it penetrates.
Yeah, you may have horizontal fire breaks to go on your ductwork for it.
Put the fire sock in.
The seal will depend on the collar will be put on.
Yes,
When it comes down, it doesn't need it just where it comes out through it, and then when the seal is broke, you need the collar to seal it.
It has to seal the opening.
If you have it in any of your apartment blocks, what you do is switch over to
We put it in the kitchen, in the timber frame house, and we put the collars on.
Yeah, exactly.
I suppose a heat pump and a heat recovery.
It's a kind of a three in one. It's not a full heat recovery, because the air it's finished with, it's not recirculating around the unit. It's dumping it to outside. It's finished with that air, and it's sending it.
What are these taking in fresh air? Sorry,
your wall vents are your fresh air inlet into the apartment.
yeah.
They're still in place, whether the wall vents are.
It's sucking your moisture, from your air. Is that what that does?
It's taking that air and typically that air is already preheated. It's in the apartment, so it's probably going to be 18-20 degrees when especially in a shower room. It's going to be more after appliances used. the kitchen it could be more. So it's you still have your as far as regs and stuff, you still have your external air. It needs air into the apartment. So that's
you need more then. You need more ventilation.
There'll be a certain size that the grills, in the design element of it, there'll be a certain size that the free air.
One of the regs you go to the ventilation. You need part F, you need that natural flow ventilation, and in the wet rooms you need mechanical extract fans.
Yeah.
They're gone when you use this system because that's acting as the extraction. It's taking it out.
Yeah.
That's what I'm just using that hot air and that moist air to be compressed.
Yeah, you'll have your clearances cut underneath your doors and your specific clearance to allow the fresh air to when you're extracting from the wet rooms, that it's pulling from the whole apartment. It's not just pulling from.
And you say it dumps what it doesn't need. Where does it dump it?
That dumps to outside to a group.
So like an exhaust.
That's exhaust. Exhaust. Yeah, it's not recirculating. There's no crossover. There's no contamination.
Right. So it dumps it out.
It's dumping it alright. Yeah. It is the bonus then of it of having this heat exchanger, having everything else in it. Then when it's up and running. Again, it'll work on the same principles as the other. It will heat the stored hot water first.
Yeah.
And when it's up and running, it's going to heat it first, and then it will go off to central heating. And it comes pre-zoned, with two motorised valves off to two heating zones. Right, yeah, because something can happen here, or it can happen in the bathroom or something. They have to know where to go. So you'd hope that you'd open the hot press door, you'd see the external valves here, you'd see that they'd be all tagged and there'd be a corresponding valve chart close by it. Yeah, so
again, that's part of the regulations as well. Any heating lines hand over information has to be provided.
And possibly demonstrated as well, right? Yeah, so it'll be all, everything's here. You won't see a switch on the wall with your sink or bath or anything else. It's going to be. It has immersion to boost the hot water, but again, that would be from the controller in the unit, and it's just hard to see. But that controller is actually down. It's an interface on the bottom of the unit, and it will be typically sitting over here. Right, yeah. So again, it's all self-contained. It's not going. If you need a boost button, you hit the boost on the unit. You're not coming in to hit an independent switch on the wall for your immersion. So, and it has if it's struggling, it has the capabilities to heat the radiators with a boosted immersion as well. And that's
what that is.
That's an inline immersion. The water passing through that and heating up as before it gets to the radiators. So
that's not moving.
No, it is, but it's just not as visible because this is just on the outside. Alright, yeah, they will have it is in there, but it's just not It's
that system is based upon there's normal ventilation within the apartment, and all it does is it takes the air that's in the apartment.
Yes. It takes the energy from that, so it has to keep replenishing, has to keep reheating that apartment to do that. Alright, yeah. So that's these are exhaust area heat pumps. There is some other systems out there for some of the apartments where it'll just be electric radiators and a heat recovery system going up in the ceiling. So that's again, that's a separate system. There's
and the control panel for that is
no. The control panel, so John, it's down there on the. It can be. There is an option to get a separate one that can be wall mounted. That if you want to use it as a thermostat in the room, it can be an external controller. But typically, it's just on the bottom of the.
Just in terms of that's all contained within the unit. So from a compartmentation point of view, it won't penetrate. There's no ducting that it has to go externally.
Yes, this one extracts on the unit itself. One extracts from the apartment. It goes in. The unit extracts the energy it needs from it. This one then goes to external. So you're going to have usually a 125 or 150 duct going to the external wall with a grill.
With a grill. Okay.
Yeah.
But there's no refrigerating gas.
There's no no. You've nothing to worry about F gas or anything else. But again, it's going to be for maintenance. It's going to be somebody that needs to know what the workings of the unit to check it out, all right, yeah, but it's the...
Generally, is it the installer then that would be doing if it's penetrating fire compartmentation?
That will have to be worked out on site with the
fire stop.
the fire stop. Again, with the duct routes, you try and keep them out of the corridor, which is the main fire compartment. So you try and sort your duct routes that is going to the less penetrations and less interaction with any fire breaks. So that's but the ducts can have purpose-built dampers.
They're like other penetration.
Yeah, they have to be dealt. If there's no other route and it has to come through your common area.
Like that comes into the manufacturer, and they have the ducting as well. They probably provide the fire collars as well.
Yeah, most suppliers will supply the fire collars with the.
Sorry, you got to be careful when you're inspecting the fire collars. Someone give you a strap. Okay, it's a strap thing.
Yeah.
That's no good if it's not compressing. Okay.
Yeah.
You may have to make sure that if it's just going through a full void, that it's fixed to a board with an actual metal collar ones.
Yeah.
They have to be fixed onto it, because if not, there's nowhere to crush the pipe if it's a fire. So just be careful with that one.
You can't interfere with the integrity of the fire breaks. It has to be.
Plus, depending on where these are coming from, their regs will not be necessarily the same as ours in regards to fire and compartmentation.
Yeah.
So they may give you a fire product to seal it, but it may not cook with our code. So don't have to use it.
Right. Okay.
Yeah. So that's. So I say that there's a number. There's about 3 or 4 different manufacturers that all make units. They all do the same principle. They all extract from the wet areas and give you your stored hot water, and then you still have your regular radiators in the scattered out throughout the apartment. One thing you see about the radiators, and same with all heat pump systems, they will look a lot bigger than what you have of a gas. A typical radiator system could be they will be bigger size than what we would be used to looking at with gas or with oil. So that's.
Just come back to your fire product then, John. If the manufacturer did send them in, the whole lot came together. If they're EU stamped or EC stamped or that we can.
You see, Martin doesn't necessarily mean compliant with the regulations.
The EU.
You have to check to see if the standard filter stock is the same standard that we have for ours in regards to the quality of that.
Right. Okay.
It's just because these are coming from Europe, they may be able to sold the products may be able to sold here, we may not be able to use it. Okay, and that's the difference in it.
The systems you're looking at for compliance, that there's definitely that you don't walk in and you don't just see that and it's not terminated, it's not going anywhere. Then that's a risk to the risk to the apartment. If anything happens, if the fail-safes blow, it's just going to flow out into the fluid in the apartment. The safety, the Fillin Loop, the system set to the right pressure. Again, if that's local authority housing, you have the choice to remove that, cap it, and leave it disconnected.
Should the gauge here read the same?
Any most typical heating systems, you're looking at about 1.5 bar working pressure, and we will have the external vessels, and you're hoping that they're mounted up at high level.
Some plumbers will actually turn around and say about 2 bar. Is that too high?
It's just if
or is that depending on the unit?
Yeah, on a heat pump system, it's probably not, because your water won't heat up to. It's not going to go above 45, 50 degrees. If it was a typical gas system and it could go up to 70 and 80, you're just not leaving enough. The safety valves on the heating systems will start blowing at 3 bar. So you're just not giving yourself that cushion, all right? Yeah. So 1.5 is probably an ambient. But again, look, plumbers and opinions. It can.
For the end user, if there's an overpressure, the valves there'll be a whistling sound. There could be some water.
There could be some water tripping out of the.
What's this thing here?
That is, again, that's part of it. It's a sensor it's built into the unit, so it's probably sensing the temp. It's a lockout thermostat, so it's sensing the temperature, and it's telling the unit.
You probably said that about 60 degrees.
No, it's only the lockout. So it's only if it overheats, it will actually trip out the unit, and it then will require a manual reset. But so, safety, yeah. Again, if something is, that should come up on the controller.
And it should be there.
Yeah, it's just part of their safety features. The controller will tell you. So it's, again, if that has happened, something has caused it to. Something.
The unit here, does it have a pipe system to dump from condensation within the unit? If it's extracting hot, moist air from the
Yes. Again, there's a drain underneath the. If I turn it up, there's a drain underneath this, and it has to pipe. That's plumb to valve as well, right? Yeah, because if you again, you're going to be inside the apartment.
And does that need to be capped, or can it be direct into?
No, it should already have its own trap in the unit, so it doesn't need to be a.
So you got to look out for that one.
Yeah, you got to look. Yeah, no, there's a condense to come off. Yeah, any unit that's sucking air is going to condense somewhere, right? Yeah, so it's going to.
And does it go through a self-cleaning cycle or anything like that, or is it just going to be whatever is present at the time? For example, is there a chance or risk of getting stagnant condensation in that unit?
No, the condensate. Again, it has to be set up to with the immersion has to be set to come on periodically to 60 degrees, yeah, and it has an inbuilt immersion to allow it to do that, alright, yeah. So that's again, because you're typically going to be storing water at 52 degrees. So yeah, the best thing to say is to do it every week.
Yeah. And that's all then connected then to our metal or pipe up here then with the screw connection. So.
Yeah, that's typically somewhere in the middle of the apartment, and you're going off from here again to your radiators. Underfloor now and again, but you're mostly talking apartments radiators, right? Yes. So, and that goes to the crimp pipe, and we have the crimp pipe expert here, Tony Kinsella. Tony supplies one type of crimp pipe. There's lots of different types in the market. Tony will tell you his is the best, right, Tony?
It is the best, yeah.
There's lots
really what you're going to find out and see as you're going around sites now is more and more there's multi-layer pipe systems being installed rather than copper pipe or PEX pipe, complete flexible pipe, you know. So the new systems now are multi-layer composite pipes. They're a composite of plastic with an aluminium inner layer and plastic again on the inside. They're basically termed as 5-layer MLC pipes. So you have a layer of plastic on the outside, adhesive, aluminium, adhesive, and plastic on the inside. The reason for this, the rise in they're becoming modern standard plumbing systems now rather than copper and PEX pipe as well. They're an advancement on PEX pipe, right? So they've combined the benefits of a plastic pipe or a flexible pipe and rigid pipe. Multi-layer pipe is, as I say, it combines the benefits of both rigid and plastic pipes. It's flexible enough to be installed as we like it now, installed through the centre of a joist by drilling joists, so it's flexible enough to get through the joist. It's form stable at the elevated temperatures it's going to be operated at in heating and plumbing systems, so it has a low expansion rate compared to a complete plastic pipe. All plastic pipes are durable. Their life expectancy is way in excess of 50 years, which is more than enough for the expected life of any product within a building. They're impermeable to oxygen, which is a very important thing. 100% impermeable to oxygen, where most plastic pipes, even with resin barriers, will allow a small amount of oxygen to penetrate the wall of the pipe, which can lead over time to corrosion in systems. Now they don't, and it's been proven, and I've sold Qualtex pipe for years myself. We've sold a barrier pipe, and you know, 25 years on, there isn't a lot of feedback coming back that it's causing problems in systems, you know what I mean? So again, PEX pipes, the barrier they have to obviously comply with a European norm, which is a minimum amount of permeability of oxygen. These multi-layer aluminium pipes have 100% oxygen barrier, so they're very healthy, I suppose you could say, within the system. So durability is fine. Impermeability oxygen, so they're not detrimental to heating systems. Secure jointing, right? So the press system will run through it there. It is a very secure type of joint. And what's more is there's no compounds needed. So we're not introducing contaminants into a system, you know, in terms of...
Potable water is perfectly pure.
Oh yeah. So there's no, you know, we're not using pastes or fluxes or that to make the joints. None of that. So there's nothing actually, the use of this introduces no chemical substances into the system. So it's a very clean, healthy system. Cleaner and healthier than copper. If you're using copper, you'd be soldering, you'd be using flux. It's not healthy to leave it in a system. It can cause problems in a system if it's not clean, etc., etc. So there are benefits. And then again, importantly enough, with multi-layer pipes, the pressure temperature ratio, the service conditions they can operate at would be 6 bar at 95 for a standard pipe and 10 bar at 95 for some of the better piping systems.
That's the max temperature.
Yeah, temperature and pressure. And if you look at the safety relief valves on these, you'll see that they can be 5 or 6 bar at 90 degrees. So what we want is a pipe, what you need is a pipe that will has a service condition, withstand service conditions higher than the safety features of your system. And that would be important when you're looking at a combination of heat pumps with sealed plumbing systems and your pipe system. Does your pipe system, do the service conditions of your pipe systems exceed the safety features of your tanks and your safety features on your plant and equipment? So you imagine using a system that could withstand 3 bar at 95 degrees, and you have pressure relief valve at 6 bar at 95. When you're not exceeding the service, you know, your service conditions are lower than the safety conditions. So you have to watch for things like that. There's markings on all pipes, yeah. There's all pipes, yeah. And I'm going, you know, as I say, there's a 5-layer pipe, just in terms of quality, right? So you know, what we want is quality products going in. Somebody where we were talking about CE marking and things like that. CE marking is a little bit dodgy, you know, a little bit. It can be a manufacturer's statement that it complies with. You know what I mean? So you have to watch. You have to look for something in relation to some what would you call it? Documentation in relation to the pipe systems that you're using, you know?
Well, I suppose one of the big things then, because for clerical works when I do in site visits, is the pipe and the fitting has to be...
Pipe, yeah, exactly. Again, I'll get to that when I go through this and go to warranties, but... so it's usually marked on the pipe 4 bar at 90, 4 bar at 95 degrees, or 4 bar at, or 3 bar at 90 degrees, or 6 bar at 90 degrees, or 10 bar at 90 degrees. We're talking about the plumbing system within the house, plumbing or heating system. Yeah, so on a heating system, your heating system will generally operate at 1 bar with a 3 bar lift off. Right. So we're looking for 3 bar and 95 degrees maximum temperature, say, which you're never going to get close to with a heat pump anyway. So your service conditions with a heat pump would be 3 bar and 55 degrees. Okay. So if you have a pipe that's 6 bar and 95 degrees, you're safe, right? So that's not a problem. On your plumbing side, where you have a pressurized system that can go to 6 bar before the pressure relief valve lifts, and it can go to 95 if you get a failure in a cylinder stat, then you could exceed the service conditions of a 3 bar pipe and that. So you're looking for a 6 bar pipe in there. Right. So the safe thing is to look for the pipe with the highest temperature pressure ratio. The ETA for certificate is attached to the front page of it there. right? That states that the pipe system is suitable for use on water systems, heating and plumbing, sanitary systems. So that's one certificate we have. And then on top of that, the ETA certificate would not be a hygiene system. It's not telling you whether it causes problems with potable water. So we're looking for something like a RAS certificate or a European hygiene certificate, which could be, I think I have the German one there, or the French one. So we don't have these in Ireland. We don't have our own. We always, as you know, we've always used probably RAS for plumbing. So it's a RAS certified, fine. So that's what you're looking for. So you're looking for a system, a cert that states the use of the product, and then you're looking for a hygiene cert if it's going to be used in the plumbing systems.
And you're looking for that the bar pressure that's on the pipe corresponds to or greater than the one that's on the system.
You're going to either get maybe a 3-bar pipe or a 6-bar pipe or a 10-bar pipe. So, you know, I can buy a 3-bar pipe cheaper than I can a 10-bar. So you're going to have to look, you're going to have to watch for that somebody's not going in there using the cheapest product they can without really making sure that it's fit for purpose. You know, so they're really
It doesn't really matter the colour of the pipe. That can vary across the manufacturer.
It will. Most of them are white with the multi-layers, but they will, you know, and like the difference between a PEX pipe and a multi-layer pipe. Most multi-layer pipes will be 6-bar. Most PEX pipes will be 4-bar. The better multi-layers are up to 10-bar. You know, so say 10-bar and 70 or 10-bar and 90 or whatever, you know, but you just have to watch that. And the last thing is the warranty. I have a copy of the multi-tubal systems warranty. So that's a warranty that's covered by an insurer. It's indemnified by an insurance company. So they have a policy, and the warranty is against manufacturing defects that cause a problem with the pipe for 10 years. So, and if the pipe has lasted 10 years and it hasn't had a problem, then it was very well manufactured. But so you'd be looking for a specific warranty from it, and the warranty covers the system, their pipe, their fittings. If I send a pipe back that's, you know, leaking or something like that, they'll say, well, it's not our fitting, so we can't guarantee the quality control in somebody else's factory, so our warranty. So this is part of the information that you will see on every pipe. It's printed on every meter on every quality pipe. It will give the manufacturer's brand name. It will give the classification, the class 2, 10-bar, class 5. So class 5 will be heating and hot water, high temperature hot water, and within the regulations, it's broken down. It'll be something like 6-bar at 95, and class 2 will be 10-bar at maybe 55. So you'll see the classifications on it. You'll have the manufacturer's production code number, so they'll be able to trace time, date, hour of production. That'll be on it, etc. And then the certifications are given on this: the CE mark, the ETA certificate number, and, you know, again, different. You may have the RAS approval maybe stamped on it, you know. But along the line of the pipe, you'll see the brand name, the classification of the pipe.
The units, some of the newer units will actually maybe have the motorised valves built into them or attached to them, but they will have to be there somewhere, right? Yeah. So it's and again, just to look out for the tidiness of the install. You'll know opening a hot press first of all, or a utility room, if pipes happen straight or pipes are crossing over each other, you'll know then to give it a tighter examination, because it's probably something that's going to be something's going to be missed. If you open it first of all and you're met with a nice impression of it, you're usually going to be everything's probably going to be all right. So you just check that the blow-offs and that they're piped to either piped outside, or you say in the apartments that they're piped to drain and trapped. So that's some of the units have their own built-in filters. They're happy to govern by those. It's a kind of a fail-safe on it. It's not just in heat pump systems, and any system, especially radiators. There's going to be metal in the system, so it's to catch that, right? Yeah. So.
Okay, I think that's it. I'd just like to thank everyone on behalf of the National Building Control Office, Meath County Council for facilitating this, in particular John Sweeney and his team in the building control section, and then Stephen and Tony from Mountain Lodge, and Tony as the pipe supplier. So hopefully this will be available on our YouTube channel for building control authorities. And again, this was just a selection of some of the products.
Just products, yeah. There's lots of different products.
Different
manufacturers.
Not manufacturers,
just
no
for display
preference
purposes.
to
No.
anything.
But the principles are all the same.
The principles are all the same, and the checks are all the same. And thank you again for your time.